Well, okay. Welcome to my old ass. Welcome to the old ass default screen. This is the old ass default screen.
It's the old power deck.
Yes. Is the stream good? Yeah. And then go ahead and announce that I'm live. And just random ad lib while we get that, ensure that works. It starts working. So editor scripting starts dealing less about making the actual, content in the game, and it's more like tools creation. And so this is more like creating things that'll help accelerate your development, or like just make your life easier in general, or just like better organize the data, because like the default presentation might not be what you want. And so this goes more into like tools development, whereas everything before was more like gameplay, or like, gameplay. Okay, editor scripting. So like I said, or like I didn't say, this is a way to add functionality to the Unity editor. So you can actually change how for example, how a component looks in the inspector. So like you can completely customize that, and Unity provides like a bunch of function calls to make your life sort of easier. There's levels of ease and control that you can basically have. But yeah, like I said, it's about tool creation, because like, what if I wanted to create a button that, said move this object in a certain way? So then I'd make an editor script that could add the button at the bottom of the component, or at the top if I felt like, to actually add that behavior to be able to actually edit, add that extra functionality I want. Okay, so there are 4 ways that you can actually edit a script, and this is a very tiny picture. So the first type is a property. This one directly changes how a class looks, and yeah, I'd zoom in if I could. But yeah, this is like very tightly controlling how a single class looks. So you know how like you could have an int field, and like that's just one thing. This is like if you were controlling what that int field looks like. You only control like what individual fields look like, so that every time that class appears, or every time that type appears, you can have this editor. What?
Wait, so it's not a type basis, or is it like I want this int to look like this because it represents, I don't know, level or something?
So there's actually 2 versions of property drawers, which is what this type is called. There's one that only affects a certain type, and there's also one that affects things that have certain attributes. So if you don't know what an attribute is, it's sort of just a tag you can put on fields, classes, whatever. And so you can either make, you can have the property drawer target certain attributes, so it filters things. And an example of that would be if y'all seen the range attribute, where you can turn it into a slider bar with a set min and max. That is built using a property drawer that targets the range attribute.
Isn't scene another one? Like where you put on a string and you just end up using something it's not a big scene? Doesn't mean a mirror uses.
I don't know about that one. Yeah, I actually don't know about that one.
Like you put a tag, anyway, I think that's what it is.
Yeah. So the next one is a bit higher level, a bit higher up. This is an inspector editor script, and this affects how a whole scriptable object or a whole component looks. So you have control right down to whether or not there are buttons, whether or not fields exist or even visible in the inspector. So this is this doesn't have as much filtering as you could have with the property drawer, and also, but it's like this one's a lot more broad. That makes sense so far.
Wait, so how do you change this? You just like.
So I'll actually cover the specifics in a moment.
Okay.
Yeah. And then another thing that targets, I believe, this targets components and scripts as well, but this is how you add like tools in the scene view of the editor. This is like So you could add like editable handles that you can actually move and have change values. So in the picture is an example of path editor that I made by basically I made the pen tool from your favorite drawing software where I use Bezier curves to be able to draw smooth paths. And so I made the editor script to have oh, you can select a node and also you can edit the node position itself, but also the tangents that come from the node. So scene is just, I want something that's visually editable in the editor. Jesus fucking Christ, words are hard. Yes.
So I'm just trying to put this to a kind of example. Let's say you have your player and there's some spawn point that's relative to them. You could either go to that and change the actual transform, or you could make it so that in the scene view you could drag that around.
Yes. Yeah, you could definitely, if you didn't want to make a new game object for that spawn point, you could definitely just make, that handle movable and using this kind of thing. A familiar thing that uses this would definitely be colliders. You notice how colliders have the, usually give you that green box and also give you handles to drag and change the shape. So that's definitely a scene editor scripting. And yeah, something I forgot to lead with is that every single window, script, and everything you see in the editor is actually going to be built with the things I talk about today. It's very advanced and very deep amount of code, but it's still founded in the same base stuff that we're going to be covering. So yeah, technically, everything Unity has in its editor, you could recreate if you really wanted to. And the fourth final level editor scripting is the highest level, which is the highest level of complexity and breadth of things it can touch, which is the editor making a whole window. So these are stuff like the animator window, the inspector, the scene view. These are whole windows that you can drag around in the editor that can have functionality that it extends to multiple assets, multiple files, affecting a whole game object. And so this is usually this is something that will touch multiple components or multiple files, and this is just the most complicated type of editor scripting you could do.
What's a use of this that you should take up?
Yeah, you want to talk about Death Vote?
I made a dialogue tree editor. So it's at the top of the window, and when you click on something with the dialogue node attribute, it would show the dialogue tree, and you could add nodes to represent what the choice is, and then go through the path. And it kind of looked like the UnityEditor window. If you've seen that, I basically just recreated it in a window for that functionality.
Basically, it was also basically graph editor, so it also lets you visually edit the node linkings and all that.
Yeah.
But yeah, this is very complicated stuff usually. But yeah.
It's kind of fun though.
And so yeah, as I said, while there are 4 types, they're sort of founded in the same thing. You'll make a new editor. You'll make a new class that extends a specific editor type. For property editor, you extend property drawer. For inspector and scene, you'll extend editor. And for windows, you'll extend editor window. So that's classic inheritance. Second, you're going to actually give that class an attribute. And like I said, how the attributes are just tagging things, you're basically saying my editor, the attribute will say what my editor class will affect. So for property drawer, you'll usually have oh, this affects this type, or it affects things with this property. For editor, you'll be I affect this type of component. And for editor window, you don't really have that because editor window, again, can usually sweeps across your whole project. And then you just have specific functions that you extend or that you override because you're in a class hierarchy, and by overriding it, you define the new behavior you want. So now here's a cool table of all the different things. Yep. Enjoy a world of information. Yeah, no, I'm not going to cover all this. This is way too much information. Holy shit. What we will do is focus on the inspector editor scripting simply because it's the simplest. It's it's sort of like the highest level without being like too complicated that I can go over right now. Because oh, this is actually wrong. Oh yeah, some minor caveats is that property. So actually, I'll cover that later. So yeah, for making the inspector editor, you just extend editor, like I said before. And editor actually provides you, after you define the class, you'll actually, or because of class inheritance, you actually get a field called target. Now, target is the class that you have, is the instance that it currently will affect. So you can sort of treat it as like, hey, this is the component I want to touch. And the only problem is that the target, you'll get it as a Unity object because you won't know what it is. So you will have to cast it into the type you want to use. And so, oh, yeah. And here's the attribute for editor. It's called CustomEditor. You give it the type of whatever component you want to edit. And also it has a second field called that is a bool. And that second field is, it deals more when your target type has a class inheritance tree. So this is I forgot this. Oh, let's see. Argument replaced with another editor. Default. Okay. So it says if there's an editor, there's a second editor that targets a more specific type, then setting this true says that more specific editor can replace me. So yeah, that's just a bit. Is that clear, or should I make an example right now?
So if you have an animal and you put this on it, and then if you have like a dog, it's always dog.
It's always a dog. Okay, fine. It's a cat now.
No, make it a dolphin.
Oh, okay, it's a dolphin.
Yay! So false means what?
So, and I have like an animal editor.
Yeah.
And a dolphin editor.
And these are both tagged with this.
Or tagged with the correct one. Because dolphin editor should be tagged with type of dolphin.
Yeah.
If it's false, I believe it's that animal editor will always be the active one.
Okay.
If it's true, then animal editor allows dolphin editor to replace it.
If dolphin is true, or
If it is a dolphin, yeah.
If animals is true, dolphin will replace it.
Animals is true, dolphin will replace it.
Because it's a class hierarchy. Because any dolphin's an animal.
Yeah.
Yeah.
Basically, you're saying,
Am I replaceable?
am I gonna?
Can I be substituted with a better, newer model?
Makes sense.
And yeah, so the function you'll actually focus on for inspector is onInspector GUI. You know, very actually nicely named for once, because the function you're overriding will just change how the GUI looks in the inspector. And so,
Wait, so it's like a markup language for function calls?
yes,
Also,
it's kind of bad.
so like if animal is like a serializable or whatever, or like can be represented already in the editor, does doing this like get rid of the default, like setting the variable stuff? Or
Yes. So what I believe happens with monobehavior, there's a monobehavior editor that has the default behavior, I believe.
Oh, okay.
And so I guess it does this to be true, to say I can be replaced, so that other editors can just step in. And so, yeah, it's just a function, and I will go over the details of how you fill this function, I think in the next slide, because I don't remember. Oh, no. Okay, actually, yeah. Okay, so, yeah, in this function, top down is the order that it actually gets drawn. So, as you see in the left example, I say make a button for A, B, and C in top-down order, and that's the order they appear in the inspector. Pretty intuitive. And however, when you start if you want to build horizontal sections, top-down goes left to right. So, it's pretty much, English reading order, except you default vertical first, and you have to explicitly be horizontal.
So
yeah.
If I started another horizontal, would just be one cell down?
Yes. And you'll notice in these examples, I say editor GUI layout. Actually, yeah, I'm going to cover that later because there are like 4 different static classes that you can call to help you build these layouts, and they all have different semantics. So I know I have slides that cover it.
So this is GUI out layout, so this works with all inspector GUI?
Yes. And yeah, like Jake said, it's like, oh, what if I wanted the default behavior back? They actually have the editor base class provides something called draw default inspector, which is how you can still recover that default behavior if you want to just build on top of it instead of just completely nuking it and making your own. So yeah, it doesn't leave you with just a pain in the butt if you happen to want to make an editor script but want to keep the old stuff. And like I said before, the order matter, the order of calls matter. On the left, I said draw the button A first, and then draw the default. So you notice the button comes first, and then a default component. And here I say button goes at the end, so button is at the bottom. All good so far?
The draw default inspector does all the GUI calls that are called in monobehaviors editor?
Yes.
If I had made an editor script that then changed like floats, would it be reflected when I drew the default inspector on that float from the default inspector?
So I'm guessing you mean you made a property drawer that targets floats?
Yeah.
So that goes on a level, like on a lower level than this. So yes, that would be reflected because you've specifically said target all floats. So basically this call would be like, hey, is there any special property drawers for the types I'm going with? Otherwise it goes to default behavior. So yeah, you can actually like nest this shenanigan with property drawers. Oh, and here's where I start talking about the different static classes. Let's see. So GUI versus GUI layout, and I say star because it may or may not have the word editor, I believe. So GUI gives you a lot more basic control where you, like a lot lower level interface where you actually have to define precise pixel size of your buttons, your text fields, whatever. You actually have to control placement too of like where the top left corner is. It's kind of a pain in the butt, but if you do want that greater control, you have that available. GUI layout, on the other hand, tries to do things more automatically for you so that you can just declare, I want 3 buttons, and it'll figure out the sizing and the placement for you based on the order of your calls. And you can have a mix of both if you do want like that automatic behavior while still some manual control. And yes, you can actually just interleave it.
Oh, okay. Cool.
I don't know what happens when you try to interleave it though. There might be edge cases that I'm not aware of because I have mostly used GUI layout because I'm a lazy butt. And like manually trying to place boxes is very annoying. And yeah, so how I said GUI and GUI, like star GUI, so there's 2 versions which are editor and non-editor. The editor versions are very specifically built for the inspector things and the window, I believe. And non-editor just has, let's see. Yeah, non-editor is just very general. And again, like I said, you can have a mix, like how you can have a mix of GUI and GUI layout, you can have a mix of editor and non-editor when applicable. Oh, and yeah, you notice how it's kind of very, it's a very declarative way of saying how I want the UI. So how do I so if I have like, if I manually create an int field, how do I get the value that was just put into the int field back out? You know, the standard thing you want in your GUI. And it's that the functions that provide you with like a user input field will actually return the output, like return the result of the user interaction. And it's all part of the system that Unity calls ImGUI, immediate GUI, saying that like your function, your calls are both telling how to draw it, but also giving you the user interactions in one place. So it's you can treat it as if it were an immediate response from the user, if that makes any sense. But yeah, in this example, I say, hey, I have an int field, and so for all intents and purposes, you can treat what goes into val as 5, because this is like the most recent thing the user put in. So this will just be filled with 5, and you know, just assume it works. Say what?
Or val is like.
I mean, val's just any variable, you know.
Yeah. Like, since I'm assuming honest what you're doing is like it takes every GUI frame, so you have to like update something outside if you want to like check for like new state. Maybe. Like, how do you know if I change it from 5 to 6?
So you won't. So if you want to check what if there was a change, you want small exclamation int field name. This is just a label you see here. Val here is what the user will see before like user interaction. So you could just store this in a different variable and compare this what you fed into the function with the result of the function, and that's how you could check like there was a change in this GUI tick. Okay. Oh yes, the other important thing when you make editor scripts that start affecting how you can like edit the values in your object, you might want to make an undo point. You know, a good old Control-Z to say I don't want to do that. And so what Unity does provide that functionality for you. It actually provides access to the undo stack in the static class undo. You know, aptly named. And so undo is actually a very complicated static class. Like I said, it's almost like full access into the undo stack and redo stack. So, for more basic editor scripts, you probably only need to worry about record object, which says, let me store the object state and then make a change to it. So then you can actually have like these restore points, because otherwise you make these edits and you can't undo it because you never put anything in the undo stack. Make sense? Yeah, I know. Okay, that's the end of it. That's the end of it. Yay. Welcome to OBS. Okay, so if you have the starter package and open, let's see, editor scripting, go into scenes and go into editor scripting, you'll see this empty ass scene because what I'm doing today is not very visual. Go ahead and click on the game object, the one non-camera game object, and you'll notice that I have two different components, both that represent a shape. So in ShapeEX, you'll notice if you actually change the enumerated shape type the fields start changing around. If I hit square, I just see side length. If I see circle, I see a radius. If I see triangle, I can set a base length, and I have a bool for equilateral. And if it's not equilateral, I have to provide a height. So you notice my bottom component is adapting to what shape it's actually trying to represent. And you'll notice the top one has all the same information, but it just doesn't hide the irrelevant ones. So what we're going to do is actually make the top script into the bottom script, because, why am I showing all these extra fields if they won't affect the current shape type? That makes sense so far? Jake, you seem a bit...
I didn't know I could do that too.
Okay. So what I'm actually going to do, so first off, I'm going to look at my source code because I'm not going to flip back and forth at it. Is this one? Yes, it is. Okay, so I'm going to right-click into the project area and make a new C# script, just like I would any other script, except I'm going to call this ShapeEditor. And let Unity think about it. And also something that I don't remember if it still affects how the code is run, but is still good, nice to do anyways, is to make a new folder called editor once Unity just stops thinking about the new file. And this folder will house all the editor scripts we care about. There we go. Okay, so now that we have this new C# file, I'm going to go ahead and open it. And so, because we're making an editor, the class actually, first off, we got to expose ourselves to all the editor functionality by adding the using UnityEditor. Because this is the namespace that contains all the editor-specific behavior that Unity wants to hide away. And now that we have exposed ourselves to everything in UnityEditor, we're going to change what we extend from monobehavior to editor. And also delete the body because these functions no longer make sense. Just giving y'all time to write that down. So now that we made an editor, let's see if it works. I'm going to let Unity compile. I'm going to click on the game object, and oh no, there's no changes yet. That's because we have to make the attribute. So now I have no idea. Okay, let's see. I forgot. Excuse me while I peek at this. You didn't see that. So we're going to add this attribute to say what? That is the wrong type. Yeah. There we go. Forgot about that. So we're going to add this attribute to the top of the editor that says this editor will now work on shape types. Simple enough. It's what attributes do. I'm going to give y'all a short moment to do that while I highlight the 3 important parts for this section before I show what happens. Okay. Anyone still typing? Okay. Okay, so now if we go back to Unity and let it compile the new script, you're gonna notice I just destroyed the shape script. Oh no! Did your custom edit? Do you have a compiler or anything? What the? Huh. Unity's being weird today. Oh. You know why nothing happened? Because we're still relying on the default behavior editor. Oh boy. Okay, so let's actually destroy the shape component by making our public, is it public? It is public. Override, because we're overriding an inherited function, void on inspector GUI. So just adding this function on top of this. So now, well, I let y'all type.
Clearly destroyed.
So yeah, now if you go to the go to Unity and let it compile itself. I've destroyed the shape component. Oh no, I can't access any of the fields anymore. But the data is actually still there. I just haven't let anything, I'm just not letting anything be visible because I still haven't defined any behavior, you know, to put in. So now, just to illustrate that you can, you know, have that custom behavior and have the default, we're gonna do draw default inspector. We're just gonna call that right in here. And then you can go back in Unity and show that the shape has been recovered. Yeah. I actually don't know what happens there. Base might work.
Base works.
Okay.
I wonder what happens if you do base with other stuff.
Oh yeah. Yeah, that inheritance might actually ruin that base. Well, it depends on what you want. It depends on what you want. So now let's actually start making that custom behavior that I talked about before. So first off, we have to get that enum field back. So what, oh, actually, first off, we have to get the shape, the instance of the shape that we're actually dealing with. So we have to do, so I'm going to make a shape variable, shape equals a cast of target. So what target is a a field in the base class that's stored as like a generic Unity object, I believe. And it's just the instance that this editor is currently working on or can currently affect. There's actually a more advanced way of doing this that I'm not covering right now because what? No, actually it's a fucking mess.
Okay.
It actually becomes much uglier. Yeah, this is actually the cleanest way to do this. So now that I have access to the shape, and actually I'm going to open the shape class once Unity thinks about itself to show that it's just a data container with everything public. And the other thing to note is that since ShapeEditor is a different class, it can only access things that the shape component lets it. You know, it can only access the public side of shape. So sometimes you might actually have to add public fields or like properties to be able to edit the things on the target class. Yes. No. Serialization is different from making things public because serialization only affects whether or not Unity will allow you to see it in the inspector. It actually explicitly must be public or have a public property for other classes to be able to touch it. Oh, and that's actually a good point. What if I have something, what if I want a public field that I don't want visible in inspector? Because like, it's weird. You actually have two options, which are attributes. You could hide an inspector or make it non-serialized. So that's also sort of like the smaller tricks. And both of the things I said are attributes that you'd just put on the field that you'd want not visible. So let's actually let the user edit the shape type again. So what we're gonna do is we're going to call editor GUI layout because we're lazy fucks and we want Unity to lay it out for us. And so the function we're calling is enum popup. And so it has two functions. The moment I can, or two arguments we're going to care about. First is the label, which is shape, and second is the value we want the user to see, before interacting. And that we're going to leave it to shape.shape, which is the shape field in shape. Shape. And so by having this function call, I'm just going to let y'all type this out, and I think everyone's done already. If we go back to Unity, and we'll notice I spelled it wrong. Capital GUI. And now you'll notice we have a new field. Yay! But if I try to click anything, I'm not actually able to change what this value is. That's because by making this field doesn't automatically make it, do anything. I still have to write that logic. So what I'm going to do is, first thing to note is that the return of enum popup is a generic enum. You have to actually cast the type back into this. So the type that we care about is shape type. And now we need to store the result into a shape type. New type equals all this code. Holy jeez.
You just do shape.
What do you mean shape? Oh, I'm actually doing it this way because you know how I said we have to add to the undo stack ourselves? I do it this way so we don't just keep adding pointless things to the undo stack. So what I'm actually going to talk about next is adding to said undo stack. So since we can't guarantee whether or not the new type and the original are different, what I'm going to do is check, was there a change? If new type is not equal to shape, let's actually do something about it. So first off, let's record the original shape. Record the original state. So we're going to call undo.recordObject. Now the first argument you pass in is the actual object you want to record. So in this case, we're recording the whole shape, so shape. The second thing is just the string to have as the message in the undo stack. So I'm going to make it changed shape to, and then make it new type. So now every time we make an edit, it should remember what the old shape was and also tell us what this change did. Now this records the object. This records the previous state. We still need to set the new stuff. So now I do shape equals new type. So now, after I let y'all type the highlighted section, yeah, this is just I sort of made it this way so if the shape type doesn't actually change, it doesn't try to record extra things in the undo stack, because all of this does execute every GUI tick, so we might end up with a bunch of things in the undo stack if we don't protect it like this. So now if we go into Unity, let Unity think about itself, we can actually click here and change what the shape is. Yay! Exciting stuff. However, you'll notice if we go to edit the message, you can actually undo. You'll see that the same message we typed in the call to undo appears next to the undo command up here. And so let's change the shape to square, and oh look, it changed. It's up there in the undo stack. So now if I actually hit undo, I can still undo it. You know, I know this seems like pretty simple behavior, but it's pretty nice to have. So now let's actually start doing crazy things with controlling what fields you have visible. So now that we have a way to edit the shape we have visible, let's actually, have the fields that are specific to a given shape. So what I'm going to do is make a huge switch statement, because who doesn't love switch statements on enums? So we're going to switch after I spell it correctly. After I don't delete too many characters, we're going to switch on shapes, shape. And so let's address these one at a time. So for circle, let's start with a case for circle. So I'm going to add case shape type circle and prematurely make the break just because I like to, because I'm bound to forget things. So here, now we can define the layout that's specific to circles. So for a circle, all you really care about is the radius. So we're going to make a new field for said radius. And like how we did the enum, we're going to make a new, we're going to do something, we're going to do something similar to shape type. So we're going to do float new radius equals editor GUI layout dot float field. The first argument is the label we want for this field, which is radius. The second thing is the value we want the user to see, which is shape.radius. And so, like I said, it's similar to the enum. We're going to have that if that checks for a change. If the new radius is not equal to shape's radius, then we do the record the shape, make the message change radius to new radius, and then apply the change. This whole thing. But you'll kind of start noticing this kind of, it's kind of straightforward. Make a field to present the user some way of editing it, store the result, check for a change. If there is a change, record, apply. So yeah, nothing too crazy. So now if we go back to Unity and we look at our circle, yay radius field. But more importantly, if we move to triangle, I don't see the radius, because triangles don't have radii. Well, they technically do, but not in the same sense as a circle. And square also doesn't have a field. And that's just to bring the point that any conditional logic will change what actually gets created in the editor. So if the conditions skip over certain layout calls, then those calls just won't happen. They just don't exist. And so we can, go along and do this several more times, but I am frankly nearing the end. So are there any questions? Because the rest of this, I can show you the rest of it because I have actually provided the finished code in the completed folder in scripts, and you'll notice I just do more of the same. I make a case for square, make a field for the side, you know, it's pretty rote from there. And then for triangle, I do one for base. And oh yeah, something yeah, booleans don't have their own bool field. They have a toggle, which is the checkbox you see normally. But you know, it's basically a bool. But yeah, you know, more conditional logic, nothing special here. So, are there any questions? Because, you know, this is just the intro to editor scripting. No?
How do I make things look pretty?
So if you, in what way?
And I like actually, is there a way to like put graphics?
So if you do, I know at least for property drawers, you can define your own UI elements and like make that custom, let me go back to the slide. So you'll notice how, you know, this used to be this horrid list of ingredients, you know, class just being expanded, and you could change it to actually be like, have arrows to edit amount and like have it all vertical and not expand horizontally. Mm-hmm. And there are ways to do this. I personally have not done this before because you do have to have like, I think it's XML. You have to have the specific XML for the new UI stuff you want to build. Yeah. But yeah, I mean, this property drawer kind of illustrates why editor scripting can be nice, because by default, Unity can just serialize it in a very unmanageable, unwieldy way, and you can change it to a much more visually appealing format. No more questions? Okay. That's it.